Hi, Paul here. Today we're going to continue this series on this assembly language x86 web server. And we went through the code, first part of the code here, the setup and what it does. In the last video. If you haven't seen that, I'll link it in the description. And we stopped at the except loop. And so first I'm going to show you what the code does, and then we'll actually walk through the code and you'll get to see what's going on. So in the except loop, we come in here, and this sets up a system call in with the Linux kernel so that it is listening. It's listening as a server when we call the system call. So we got the IP address from above, we got the port, it's running on port 8080, and we set up the socket connection, and then we bang the system call, which actually turns the server on and gets it listening. And then we pass the client ID from RAX into the client ID. So when we set up the system call here, it returns a client ID in RAX. And then we add that client ID to this variable that we created at the top called client FD. And so that holds the client ID, and all through the application, anytime we need to refer to it, like here, we have it. Okay, so then the next thing we do is we do a read request, and we read the buffer string. Once we get a signal in from the into the server, there's a buffer variable, and the system that was listening now starts to activate. And so it reads the request. Then it prints out the first 100 bytes of what that request is down here in the terminal. Okay, so we'll get to see that. After it prints that out, it checks the method of the request buffer. It looks at the EAX, which is a 4-byte register of the RAX. So this is the lower half of the RAX register. And it looks for the word post. Is it post? Now, of course, you know, it uses the little Indian, big Indian scheme, so the hexadecimal is written backwards, right? That's just the way the computer stores it in memory. So it actually is written in memory as TSOP, post, in reverse. Okay. If it finds that post is in the command, it'll go to the post label and continue. So if the incoming buffer, the header from the client comes in with post, it automatically knows that there's some post information that needs to be processed. It'll jump over to handle post request. If that's not the case, if it doesn't equal handle post, then it doesn't jump to this, it just falls through, right? That's how ASM assembly language works. It's sequential. It just falls through. That's all. When you're dealing with ASM, just remember that if you haven't figured that out already. This just falls through. It's not like higher level programming. So everything is handled by jump commands, either JMP, JE, JZ, JLE. I mean, these are just commands that tell it where to jump. Now, it can jump up, it can jump down, but whenever it jumps, wherever it lands, it continues sequentially down. So that's something to help you wrap your mind on how this code works. So each of these blocks down to a system call like the system call, this block here, this block here. They are all setting up system calls to carry out a command, whatever it is that you're trying to get the program to do. So now we're down here. If it's not post, if it was post, it jumped down to the handle post request, which is further down. Since it's not post, it's got to be get, right? It's either get or post if it's an HTTP request. So then here, it doesn't even need to check to see if it says get backwards, TEG, because it has to be get, right? So it comes in and it does, it stores in RDI, just like it did up here, it stores in RDI the address of the request buffer. Then it moves to AL, which is a smaller registry entry, it's just 1 byte, and it moves a space into AL. So it's space separated by 2 single quotes. It moves 1 byte character, in this case a space, into AL. Then it jumps to a subroutine, or a subfunction. It calls a function called find char. So it's going to look for this space. And what it's looking for is the position right after the T. That should be a space in a normal HTTP GET request. It's going to be a space. So we got to find that space with the ASM code so that we can continue from there. So we want to get to the space that comes after get, because we already know it's get, so that we can look at the next couple characters and find out what we're dealing with. What kind of command is this get? What is it looking for? So it calls find char, jumps down there, and we'll walk through this in a minute. And then it comes back and it does a comparison of RAX. Basically what this does is it sets the 0 flag. If these are equal, then it would be a 1. There would be no, the 0 flag would be set to 1 because it would be true. This equals this, that's true. The 0 flag in the flag register would be set to 1 for true. So then it comes down here, jump if 0. Well, if it's 0, then obviously it would go to send a 404 error. It should be not 0, right? It should not be 0. If there's a 0 there, there's a problem because we just set it to 0. We test if it is 0. If it is 0, then we are all set. If X is 0, no correct data was found. So that means that there would be nothing after the get. All we got was GET, no space, so no more text. Well, that's an invalid get command. It has to have what it wants, right? It's saying get, just like you would go to the store to get milk. You got to get something, right? If you're not getting it, why go? You're not going to the store just to get. You're going to the store to get something. Same thing here. We're going into this find char to get something that we're looking for. So if there's nothing there, we go and we send a 404 file not found error, right? Just common sense, right? Okay, then we assume that there is something there because we didn't jump here. We fall down again. We fall straight through. We increment racks. So we add 1 to racks. And then we move racks into R13. This is where the path starts. So when we come back from here, racks has the current location of where the path starts after this space. And we move that into R13. R13 is a variable we can use, a register we can use without worrying about the system overwriting it, because racks constantly gets overwritten. So we got it there. It's a placeholder. We know it's there. We know what the path is or where it starts. Then we start looking at, well, what is it we're getting. See, we already left a space. Now we're in a slash something. We're looking for something, right? And so we want to check and see if it's the logged in page. Are we trying, has the person entered credentials in a login form, and are we looking for the logged in page? If we are looking for the logged in page, it would be in this compare. We would compare what's in, we would move the stop pat into RDI. We would look at we would move the logged in path, which is a variable defined at the top of the program, into the location of the logged in path, which is a string. We would move that into RSI, which is actually this string. And then the logged in length would be the length of the sides of this file. We move that into RCX. And that's so that we know what to tell the browser. Okay, yes, here's the data, and this is how many bytes we got to read of that data to get the full thing. So if this equals this line, this would equal this number of characters, and then we would do that compare, and then if it's equal, if this is correct, if it equals this, the logged in path that's in that we moved into RDI, then we would jump to serve the logged in, and this function or this routine would run. And this is further down the page, and basically this would send this logged in page to the browser. Okay, but if it isn't logged in, then we need to know, is this get command looking for the index page, the home page? And again, we move the starter position is still in R13. We move it back into RDI. We put the memory location of index pat string, which is this HTML page text. We move the beginning location of that in memory into RSI, and then this would have the length of that HTML file. We move it into RCX. Basically, it's the same thing. And then we do a compare to this file and this string. If it's that, then we serve the home page. We serve the index. Again, another routine farther down the page. If it's not that, we fall through again. So it's not the login page that we're looking for. It's not the index page. Maybe we're checking to see if we're logging in. Is it looking for, are we logging in? Is that what we're trying to do? Have we already got the index page, which has a form, fill out the form, click the submit button, and we're coming in with parameters instead of a post. In other words, we're coming in with a get, like it would be something like, well, I'll put it here. It would be something like this, get slash index HTML and that username equals admin, pass equals 1 2 3 4. This is sending it as a parameter in a get string. So this would be the get string, but we're not doing that. We're actually using a form that sends it as a post. But if somebody literally typed this into a browser, it would come into here. It would fall into this. So what does this do? Well, this, again, R13 has the starting point, which is this slash, and it compares EAX, what this is. It has the whole buffer here. It compares that to, again, this is 4 bytes, right? EAX is the lower part of RAX, so it's only 4 bytes. It would actually have this. just that. So it compares that to this, but written backwards again, and it's backwards here. And if they match, if they're not equal, if they're two different things, then it's not looking to log in, so it jumps to not log in. If it is equal, if they do match, and the words are matched, the first four bytes of R13 matches in, because we already did log, now we're checking 4 more bytes, R13, plus we're moving the pointer down 4 more bytes, so we left this and we went to at least in and something else. Does it have in, in, log in? If it does, then we check the login. We go and validate, is it valid? Are these credentials correct? Is the user really admin? Is the password really 1234? That's where we jump down to check that login information. But if it was not logged in, if it was not beginning with LOG and these first 4 bytes, then we know that we're not logged in. We jump down here anyway. We come down here and we do this. We check, is the get command, instead of /login, /index, is it /API? Are we trying to make an API request? And it does the same thing here. R13, it jumps here. If this is equals, if EAX and equals this, which would be this, then we check the API. We jump down and see if the API key is correct, right? I mean, you see how this works just like in higher level programming. Now, if you don't know any higher level programming, I'm sure I'm just confusing you. But if you know high level programming, you know how this is processed in like C or C++ or Java or Python or whatever. This is the normal approach for it, right? For talking to a server. Okay, so if it's not API, it's not login, it's not index, it's not any of this, then we just check if it's slash. If it's just get slash and nothing else, then it's the it's coming to the main domain, right? Like localhost, whatever this server is called, right? In this case, it's localhost running on port 8080. So there's get, and that's it. Get slash, get the root, get home. Python, it would be root, right? Get the root. And so we compare 1 byte of R13, the first byte of this buffer, we compare it with the slash. And if it's the slash, if it's not the slash, let's say it's get x. Well, that's not valid. So if it's not equal, if these things don't equal, then it's a 404 error, because there's no such thing as get x or get z or get 1 or get n, you know. So it's going to jump down to send a 404. But if it is equal, it's going to continue down. Is it followed by a space? Is this, where this is, plus 1 byte more, a space? If it is, then again, it's going to send a 404 error, because get slash space is not valid. Or, you know, so that's the last check here. And so if that's all okay, if there's something after that and it's not a space, or it's just that, in this case it's just that, then we want to serve the HTML page. We want to send them the home page. So we jump down to serve HTML. And then this is when it jumps down, these are the places that it jumps down to, right? So it would jump down to serve HTML, which is right here, in which case it would serve the HTML page. If it was looking at login, it might jump down, check the login information, come back here and send the full file for login, successful login, because the username and password was tested and they were correct, so it sends the success file. In this case, it's the logged in HTML page, so it sends it. But since we already passed that and we're now looking for just the index. If we jump down here, file name is index.html. We set that at the top. We set the R11 to the memory location of where this starts, this file, and then we do an XOR here to set R10 to 0, so R10 is now 0, and then we jump to send the full file. This function jump send full file is what sends whatever page it is that we want to send. Do we want to send the index page, the logged in page, the success page, whatever we want to send, API, this is the function that does it, send file full. So, now if it was post and not get, it would have jumped down here, right? Handle post request. And so this is where the form field would come in. If you submitted a form, it's coming in as post, not get. It's going to be post variables. So it comes in here. We move the request buffer address where it starts into RDI. We put AL back to single byte of a space. We call find char. Now here we jump down and we look for this space to find out what's after post. Remember, it's the same as get. It would be post space something. So we got to find that where that space is located. So this function find char does that. We pass in, we call find char. Find char looks at AL, sees that it's looking for a space, increments through the buffer until it finds the first space. And then we do a test of RX. If it's 0, we jump to file not found. Same thing, right? If there's invalid characters, we just send them a file not found error. If it's correct, if there's something there, we go down and we continue. We know the path start is R13, so we move. When we continue, we increment racks to get past the space. Now we're at the next character because we added 1 to racks. So we move that location into R13. So that's where the path starts. It could be this, right, for index as an example. But it's past this space. So the next thing would be a slash. So we're going to check and see if it's index. And that's what we do here. Same thing we did in the get. We're doing the same thing here. If it's not a post index, then we jump past this. If it is, we continue, and we get the index length, and the index string and the index length. We put them together, and we jump to check login. We go see if it's got login information. And anyway, then we do the now we handle the get request, check logged into our HTML. If it was not post, then we do this and we send the login page. If it's an index that they want, we send the index. It's login page or login request. We do that with the parameters. It looks like we're repeating it, but remember this is under post. The other one was under get. So not logged in. If we're not logged in, we do this and we send them the root page, the basic form, so they can log in. And we serve it, and that's the index page. And then if they are logged in, then we serve the logged in page, which is the success file. And then this is the function that sends whatever page we're sending. This is the procedure that sends it, or the routine. And so to send a file, this is what happens. We send the full file. Rax has the location of the file. We move these in, and this is for read. We set Rax to 2. At this time, Rax is now overwritten with 2, which is the read command in ASM. And then we move R11 into RDI. That's not really, that's just setting up the information for the syscall, we set ESI to 0, and we do the syscall. That tells the kernel we want to read a file. Then we got to check and make sure the file exists, because if the file's not there, then we got to jump to send a 404 error. So we check RAX, is it 0? If it's not 0, it should be 0, right? Because we're sending it there and getting a response from the server. If it's wrong, you know, if it's less than 0, like -1 or whatever, we jump to a file not found. But assuming it's good, we continue. So the file ID, we move the location into the file ID. Then we read the file. We open the file and read it. We set EAX to 0, which is system read. And we move the file buffer from this file, which is the actual file information. We move the address of that into RSI. We set a buffer length of 8192 because we don't know how big the file is that we want to send, right? Could be a very small index page, HTML page, or it could be a long HTML page. 8192 is a pretty good size HTML page. Now, if we try to send a file bigger than that, we're going to have an error because it's just not going to fit, right? It's not going to fit in this buffer. This is the size of this buffer. So we read the text file into this buffer up to that length. Then we do a system call, which actually reads it and fills the buffer. And then we move the response from the system call into R13, which is the file size. And we need that because we got to put it in the header. When we send the header to send the file to the browser, we got to send the header first. And then, of course, after we read the file, we got to close the file, right? Or we have a memory leak. So we set RAX to 3. We pass in the file name, the file location, and we call syscall, which closes the file, right? And then we calculate. Here's where it gets a little tricky. We have to calculate the total content length, the file size plus any extra information. So we add R13 with R10. R13 is the file size. R10 is any error message or any message, you know, thank you for logging in, or we're glad you visited our site, or anything extra, right? That's going to be in R10. And R13 is going to have the actual size of the file. Okay, we get that here when we read the file. So now we're going to send the header, and this is send header part 1, the content length. So we we connect to the client again. We pass in the HTML header that we've already defined, and we pass in the header length, how long the header is, and then we do a system write, and that sends the header to the client, at least the beginning of the header. Then we have to convert the file size to a string and send that. We're continuing the header. The reason being, the file size is in hexadecimal, right? Because we're in ASCII. We're reading and writing from the actual registers in the memory, so it's in hexadecimal. However, browsers and HTTP protocol needs the file size in ASCII, in numbers. It needs it in ASCII number, an integer. It needs an integer. How big is this file and how many bytes is it? So we got to convert the hexadecimal size of the file to the actual integer size of the file as a string. So we can send a string through to the header, to the browser or the calling agent. So to do that, we call this ITOA buffer, and we pass this information to it. We call ITOA, integer to ASCII, because we're converting it from hex, binary to integer to ASCII. So integer to ASCII is the function that actually converts the integer value into an ASCII string that can be sent as part of the header. And so then we send that, we add that to the header return information, and we move back the return from this call, we move it into RSA. That's the address from the ITOA of where the string begins. RDX already has the length of the string because in ITOA, when it's converting it, it's actually counting the characters, and so it places those into RDX. So RDX at this point has the length of the string. So say it's 1,025 bytes or 1,025 characters, then this would RDX would have 1,025, which would be the length of the string, and RSI would have the actual beginning point. So the ASM would go to that beginning point and well, it would tell the browser that this is how many bytes of data we're sending to you. And this is, again, part of the header. And so then the client ID is fed in, and we do a system call, and we write that to the browser. And then we send the end of the header, which is carriage return, new line, carriage return, new line. So we send that in. That tells the browser that I already sent you all of the header information. Now I'm going to send you the file, okay, or the response, whatever that is. So in this case, we connect again to the client ID. We move that back into RDI. We send a header end, which is this string, and the length, which is the number of characters in this string. And we set 1 to RAX, which is the close of the header. We're still dealing with the header. It tells the kernel that. And then we call a system call. Now the header's been sent. Now if there's an extra message, like login failed, or, welcome to the site, whatever, we're going to send that now. So we're going to do a test of R10 with what's returned with R10. And if it's 0, we skip the extra. If there's no value here, if the 0 flag is 0 because there's no data, then we skip it. There's nothing to send. Otherwise, we're going to add it to the string that we're going to be sending. So we got the client ID, login fail message, because that's, in this case, it's definitely login failed in this code, because we're not sending any other messages in this code. So we add the logged in failed to RSI, we append it in there, and then the length of that message, logged in failed, the number of characters, we call a syscall, all that. But if there was no extra message, if it wasn't logged in failed, we would have skipped that whole block and come right down here, right here, skip extra. We would have skipped that and come down here. And we would have continued. We'd send the actual HTML file body. So we connect there, we get the file buffer location, we know the total size is R13, we move that into RDX, we subtract R10 because there is nothing in it, so there's no problem here. We subtract that, RDX stays the same because we're subtracting 0 from RDX. We move 1 into RAX, which is system right, and we call system call. Now we wrote the file buffer information to the browser. Then we jump close client. We close the client because we're done. We sent the file. Everything's okay. Had it not been get or post, it might be API. And then if it was API, we had already said that we would jump down here and check the API to make sure it's correct. If it's correct, in this case, we're just assuming it's correct. Actually, the API request here just means send me the HTML file. So we send the file. Now, this file is actually in the header. And again, if you look at the previous video, you'll see where we created it. It's not a file we're sending. It's actually text in a buffer. And it's in this response buffer. So we're just sending that directly to the browser because it asks for the API. Of course, we got to get the API length. We got to look for the buffer and call this to get the string value to send to in the header again, and we do all that again. We send the header with the terminators again, and then we send a JSON encoded API text. So this server actually handles JSON, which is really cool. So it'll send a JSON file that it is written up in the top of this file. And then this is then we close the client, of course, because we sent it. And this is the send 404 error. So anytime there was an error, some invalid request, this is where we send the file not found, right? Again, that's just text. It's actually this not found res up at the top of the page in the data section, and this is the length of that, and we send that, and we close the client, And then check login. If they did try to log in and it was a post, we come in here and we do a compare and check the login to see if it's accurate. It's pretty much the same, right? It just goes through, finds the char. If there's no string, if it was a get, it should be, the address would be after the question mark, the parameters. If there's no parameters, then we send file not found. If there is, we continue. We pass the parameters that come after the question mark. If it's post, we come in here and we just check it against this buffer. And we look at these letters. We send these letters in this way to close the send the body, right? And this is because we're sending JSON, so we got to send these in as formatted JSON. So return new line, return new line. Next byte body, we send get the request buffer. We add 1,000 to racks, move 1,000, or we add 1,000 to racks, which gives us the buffer length for API. In this case, it's under 1,000. And then we send that right here. We find the body and send it. If there's an error here, we send the 404. Once we found the body, we move RDI 4 places, and that's where the body starts. And we get the pointer. We look and see if it's user admin pass 1 2 3 4. Now you wouldn't normally do this. You could put it in a file, right? That was secured instead of hard coded, but we're hard coding it here. So we check in. We're looking at user equals, and then the parameter pass equals, again in the parameter, and we're just basically checking it here. And you can look through this code to see how that's doing it. Then we jump to done parsing anytime we find a match. We're using find char each time to find a match. We check the user, check the username and see if it's valid. And here's where we find the and sign. It ends with a delimiter. We check for the password, and we get login failed or whatever. And we check the password here. We verify the password is correct. 1 2 3 4. So we check that against the admin password. Up here we had the admin user. We checked against that. Those were defined at the top. Admin user is admin. Password. Admin password is 1 2 3 4. And we're just verifying. We're just checking to make sure that that's what it is. If it's not, logged in failed. And we send a fail message. If it's correct, then we send the login is successful. So we come over here, and now we connect to the client again, and we send a redirect, a 302 redirect. So it's going to redirect the browser to a new page, and we send it to this redirect page, which is, again, recorded in the data center. This is the length of that. We call a syscall. And then we close it. And then we jump back to accept loop. We sit back and wait for another client to connect to the ASM. And then, of course, this is the error, exit error. If there's an error, we exit here with a code of 101. If there's an error creating the socket, or this is binding the socket, this is creating the socket. If there's an error creating the socket, in other words, if the server fails, we're going to send these error codes and basically set those error codes, and basically they would be written somewhere. And then this is IOTA, integer to ASCII converter. So this is a really cool routine. It loops through, it takes a byte, and it loops through, and it compares that byte, calculates that byte to the ASCII equivalent code. Convert remainder to the ASCII digit. So that's done right here. And so, right in this section. So it just does that, and it stores the digit into RDI. So DL always has the ASCII code, and it's added to RDI, and then we increment RCX to the next one. So here we set ECX to 0, then we use an ECX as the character counter. We're actually counting. And so we come in here, we set EDX to 0, we divide RBX by 10, because this is where we set it up here, RBX 10. So we divide EDX by, we divide by 10, the remainder in RDX. So the remainder of the division of RAX divided by 10 goes into RDX. And then here we convert the remainder to ASCII, whatever the remainder is, we convert it to ASCII. And then we move the buffer pointer backwards 1, because we're moving from the end of the file to the beginning of the file, right? So we got to move the buffer back. And so we do that. We move RDI, RDL, which is wherever the buffer string was. And we're just doing this from the end of the string to the beginning of the string. And each time we're testing RAX against RAX to see, is it 0? Is the quotient of the division 0? And then we, if it's not 0, we loop again. In other words, did we get to the beginning of the file? If we're done, if we went through every character from the end of the string to the beginning of the string, we jump to loop if we haven't done that. Then if we continuing, we move RDI into RAX, we move RCX, which is the increment, this is our counter, we move it into RDX, and we return. And we come back, we got the information, RDX now has the length of the string, and RAX has the start address of the string, and that's what's returned from this subroutine. This is the find char. It works the same way. It basically loops through looking for the space, or whatever it is we're looking for. In this case, we're looking for the AL, which has the space, right? If we look at the next character in the in RDX in the buffer, right? We read a byte from RCX. If it's 0, we stop because there's a problem. If not, if it's not null, we can keep going. If there is a character, we jump if equal to not found. If it's equal to this 0 or null. But assuming it's not null, if it's a valid character, we compare that to the space. If it's equal, we found it. If it's not equal, we increment RCX, so RCX goes up by 1, and we jump back to loop, and we go through again. And we compare RCX, where we're at now, with the space. And once we find where they equal, where when we find the byte that actually equals the space, in this case, we jump to found, we move RCX, the counter into RAX, this is where we know how many bytes in the space is. So if it was searching this string, we would go through 1, 2, 3, 4, 5. On the sixth attempt or sixth time through the loop, we would find the space. We would send 6 here into RAX, and then we would return. And now when we return from the function, RAX has the position of the space in the string. It doesn't have to be a space. We could search for anything. We'd search for N, H, whatever we want to search for. Now it'll only search till it finds the first occurrence. You could make this subroutine larger. You could use another registry like maybe R15 or R14 and use that to store the number you want, like how many times is it found, and you can keep going until you get to null. And like if you were searching for space, you could return in, say, R14 1, 2, 3, 4, 5. You could return 5, which would say there's 5 spaces in the string. Or it may be that you want to send down, I need the third space. So you could put this loop going through until you find the third space by passing another register, R14 down, set R14 to 3, send it down here, and loop through that way. Okay, I know this video is getting long, so I want to go through it a little bit so you can see what's going on. So what I'm going to do first, down here I already got it pre-filled. I'm going to actually start the server. Okay, I'm going to put in my password. Alright, now the server is running. We come over to the web page. You'll notice I'm at this address. There's nothing there until this, because the server wasn't running. Now the server is running. Hit enter. There it is. It already went through, contacted the server, the ASM server, and said, send me this request at this IP on this port with no other get information. So at this point the server said, oh, it went through, did all its tests, says it wants the index page. So it sent me the index.html page, which has the login form. So now if I put in the correct login, or better yet, put in the wrong login, we'll get an error at the top. That could be moved down here and formatted pretty. I just didn't take the time to do it. But if we put it, and you notice we're now on index.html, it actually updated this and sent it. Because index.html is the default page in a web server, right? But if we put in the correct password, we get Google's warning that it's not on HTTPS. We get the page, and this is the actual logged in HTML. So it sent us to the logged in page. It validated the username and the password. It was correct. Here we are. And then these open, you know, Google, right? GitHub. So you can make this HTML page whatever you want. You got 8,000 something bytes to work with, which we talked about. And then this returns, logs out, turns you back to this. Now, if I didn't want that, if I wanted the API response, I could change that to API, as we did last time, and there's the JSON returned API. You know, so this could be any API, right? But this shows you how the server handles API. Now again, this server, just for a reminder, is totally written in ASM. There is no libraries, no other files being added. It's just strictly ASM. So if we come down here and quit the server, okay, now we go back to the home page, get rid of the API. it's not running, right? We can come in here and come back to the top. I got a break. Actually, we don't want to be all the way up. I want to be right here in the except loop. I got a break here at the except loop. I'll also put one here. Actually, no, I'll put it here. So now if we debug, run it in debug mode, okay, the server has started. I can refresh the page. And we're now in. The browser has just said, send me this page. I sent a get command. Now look at how it works. So we're here. So the accept loop stops because the browser just came in and contacted this ASM page. If we step through, we get the pointer to the IP address for the buffer. It goes through, and at this point, it has the IP address of my server, right? That sent the request. The kernel supplied the byte size of the IP address of the buffer. That's all being set here. And then 41 is the socket and 43 is the connection to it. So 43 is the socket connection, and we just created that. And if we go through, so now we got the socket here, and we just moved it into this client variable. That way we can use it everywhere. So here it's being used again. We're reading the requests from the buffer that just came in. And then we come down here and we debug print if there's an error. So we debug print the first 100 bytes so we can see it. And if you look down here in the terminal, you'll see it right here. We're sending the buffer, first 100 bytes of the buffer in this system call. There it is. There's the first 100 bytes. So what came into the server is get space slash space HTTP protocol slash 1.1. The host was 10.0.0.1 on port 8080. And the connection is keep alive. And the cache content is max age equals 0, and then it truncated the rest. But this is the header that came in. So that's what come into this to here. That's what the request buffer has, all of it, not just the first 100 characters. So we jump through. We set EAX to 4. We would get 4 bytes, and we check. Now we just put 4 bytes into EAX from the buffer. Right, that was added to RDI. We check, is it TSOP? Is it equal to TSOP in hex? If it equals, then we handle the post request because it's a post. It's not a post, so it jumps down. We do the same thing. We got the request buffer. We check for a space. So now we're going to iterate through the get because we know at this point it's get. And we got to find the space. So we're going to jump down. We added space to AL. We jump down to find char. We come into the loop. We jump through the loop. We compare RCX, which has 1 byte of the string, the G in this case. And we look, is it a space? No. So we increment RCX. We jump back to loop. Now we're looking at the E. Right? We're looking at the E down here in get. We come through. Is it a space? No. So we keep going through. We loop. Now we're at the T in get. Is it a space? No, of course it's a T. So we go back through. Now we're on the space. So we come through. It's a space. Ah, we found it. We jump down to found. We move that number, which in this case is 4. Actually, I think it starts with 0, 1, 2, 3, but it's the 4th position. We move that into RAX and we return. So we found it. We know that the first space is in that position. So RAX, we test RAX against RAX, and we know that we found a space. So there's no problem. We keep going. We don't jump to error, not found. We increment back, so now we're at the next space, which is the slash, right? And so we check that. That's the pat start. We put that into R13. So now R13 is where we're going to begin. We're checking for logged in. We move R13 into RDI. We move the logged in path address into RSI. We move the length into RCX. We do that compare. Are we looking to serve the logged in? Is that what's happening from R13 on? No. So we drop down. We don't go to serve logged in because we didn't ask for the login. Is it index HTML? Yeah, it is. So we come through. We check it against index.html and the length. We do the compare. And yes, it is. No, it isn't. It's a space. That's right. Because we're at the slash, right? So then we check it against logged in. That was my mistake. We look at the first 4 bytes against /log. Nope, it's not that. So it's not login. We come down here. We move. We check for this. Right. We jump if it's equal to check API. Is it this? No, it's not. So then we want to know, is it the root? So we come down here and we do the compare against that. It's not a space, so there's been no errors. We go down and we serve the index page. The index page is here, so we send that. There it is. There's a no bug, send the full file. So we jump to send full file because we know it's the index page. We come down and we set all this up. We connect to the file. This is the actual file name, and then we read the file, and now that's in the buffer with a maximum of that many characters. We come back here, we close the file. We calculate the total length because we got to have it in text. Remember, ASCII format. So we set the client, we set the header, we start writing the header information. We come down here, now we're going to go and read the buffer, and we're going to call IO. So now we passed the buffer down here, and we're going to go through. We move to the end of the 16-byte buffer. Remember, we start at the end and we move forward. So we're going through these and checking, and we're just going to keep looping until we find the length. Now RDX has the length of the string. So we return, we move that into RSI, connect to the client, and we write the header. We send the end of the header. And then, is there an extra? No, there's no extra. So we jump down here. There was no login information. We get the file. We read the sides. We jump to close client. And if you noticed in the background, the home page popped up. That's when we get here. Now, let me make sure I'm out of here. We close the client. Let's get the client closed. Do the system call. We jump back to accept. We come through, and now the server's waiting for the next response. We type in admin, put in the right password. 1, 2, 3, 4. We click login. We come in here, and the server got the request. We come through, and I'm going to go a little bit faster here. You get the idea. This is what the code is doing. It's going to print the first 4. That's what we asked. We did a post to index with the information. So we come in here and we check, is it post? Yes, it is. So we jump down to handle post, and we set the buffer into RDI, or the address of the buffer. We set AL to the space again. We go down, we find the space. And then we come back out. RAX is at that position. come down here, we check against for post. It is post, so we keep going. We get the string length, we do a compare. We're going to have to check login because now we know we want to log in. So we make sure it's post, we come in, we handle the post request, we get the request buffer, we find the body. Yeah, we found the body, so we jump down here, next byte in the body, and we read that. It's a safety check. We come back in, we read the next. So basically this is looping through till we find the entire thing. So I'm going to put a break here. Here. Yeah, okay. Well, anyway. I'll just hold it down, we'll get there. It's going through the entire HTML file, character by character. Let's see. All right. So that was fast. I wasn't sure that would work, but I haven't used this debugger yet. Okay, so now we're going to loop through the params. Is it a user? Yes, it's a user. Is a user, and then we're going to check, is the username correct? And we come back and we're going to do the same thing for the password. We're going to set up the registers for the password, and then check and see if they match. We come back in here, we're done parsing, there was no failure, they do match. We come down here, we check for the user again, check the password. Okay, we got all that. Now we know it's right, now we send the file. So we come in and we set up the right buffer. And we send a redirect. Okay. So we skipped the extra. There was no extra. And we sit back. Yeah. Okay. So I think I did that too fast. So let me just go ahead and hit continue. You know, when you do that, it can be too fast for it to get to the... At that time it took it. So now we need to get back to... Okay, we are. So there it is. It did it. When you're walking through, it's not the same as letting it free fly, right? Walking through is slow, registers get timed out, whatever. But it's sent to the page. And of course, if we did the API, it would be the same thing. It would check to see if it was API, it would jump down, and it would just send the API. So anyway, I hope you found this video interesting. I will make a follow-up video probably with a little more detail. But right now, I think this is pretty good. And I will share the code. I guess I'll put it up on GitHub or something. I'll share the code. I don't know exactly how yet. And I'll put it in the description. But I hope you found this interesting, and thanks for watching. Have a great day.